Right, let's look at the absolute value inequalities in a bit more detail, and but we'll also keep in mind what we have learned from the graphical method. All right, so let's see absolute value of x is greater than some k. I'm taking k to be a non-negative number. Now recall the two parts to your absolute value. It is itself, or you have a negative, and I'm purposefully doing something here, x minus k. So nothing to do on this part, but the second part over here. Now, as we saw on the last part when we were looking at the graphical method, we saw that the greater than symbol, this was an or statement as a combined inequality. So you must put in the word or. If you did what I just did in terms of the black writing, and there's no conjunction, there's nothing to join these two things together, whether an and or an or, you will be penalized. All right, so do remember which one is an or statement and which one is an and statement. So to compactly write this, we had the absolute value of x is greater than k. Your textbook will write that this means that x is greater than k, or x is less than negative k. All right. If we look at the absolute value x is less than k, again, if we go back to our graphical method, this was really an and statement, but let's break it up and see what happens first. We would have the absolute value is just itself. We'll use the word and. We have absolute value of x could be negative x if the what's inside is negative. Let's simplify here. That is, we're going to divide throughout by -1. If I do that, then there's a reversal of the sense of the inequality. It changes direction. So in the first case, this is one way that we can write this. Absolute value, when absolute value of x is less than k, it means, and there are going to be two meanings. So first meaning is here x is less than k and x is greater than negative k. You don't have to remember anything much, just these words. Is it an or is it an and, if you decide to, particularly if you're deciding to work with the less than sign, right? Or less than or equal to. All right, now as I mentioned and as we saw also, when we put these things together, providing k is a positive number, there is a combined way of writing this, and we end up with a combined, not just combined, but it's a little bit more interesting, a little bit easier to work with in some instances. We say that x is between negative k and k. All right, so let's work with the or statement. That's a bit more straightforward, and what we're going to do, we're going to look at a few problems and we will see what happens as we go through. Right? So, okay, suppose we had solve and graph the following. Absolute value of x plus, say, I won't go too far, x plus 1 is greater than or equal to 3. I can look at this. I see already that the absolute value is on the left hand side. There's nothing on the outside. I don't have to change anything. And so I am prepared to start working. So in working out my solutions, I will say that this is an OR statement, right? So whenever I have this inequality, it means that I am looking at an OR statement. So I will have, let's write the two parts. Just itself is greater than or equal to 3, or the negative of it is greater than or equal to 3. Let's simplify each part. So removing the bracket, grouping all the numbers on one side. Negative x minus 1 greater than or equal to 3. Negative x is greater than 3 plus 1. Won't be doing this. Alright. If I now divide both sides by negative 1, remember that inequality. Negative x over negative 1. If I'm dividing, I'm going to be reversing this. And my solution is, or simplifying, we get x is less than or equal to minus 4. Right? Now remember, this was an OR statement. So what did we do? By now, having done quite a bit of these, you should be able to go directly on the number line, but I'm going to take it a bit slow at first. Let's look at each of these and then the OR statement. So if I look at the first inequality, I would have x is greater than or equal to 2. Second was x is less than or equal to negative 4. Let's put in a few markers. Here's my 0. I would have 2 somewhere on this side, negative 4 somewhere over here. Of course, we do the same. And let's highlight what we have. So if we look at this, the solution would be x is greater than, and let's do what I did. We'd have everything above 2. When we work on or look at the other side, 4 is included, everything below 4. Now if I'm doing the OR statement, it's really the union of these two sets. And as we go through, this union would just be the putting together, the bringing together of these two items. Everything that is shaded on the number lines, on each number line, will be a part of the final solution because the OR meant a union. Okay, so we end up with the solution that's shown. We can write our solution set. Our solution set is a set of x's such that x is less than or equal to minus 4, or x is greater than or equal to 2. Again, if you don't remember your combined inequalities, please go back to the video and check out the lecture on that topic, combined inequalities. Right, so let's keep working. Let's still do another with a greater than sign. So here we had the greater than or equal to, and hence our solutions also had that equal sign in them, right? Okay. All right. Now, it doesn't matter, same methodology if I had just a greater than sign. Okay? So, doesn't matter. Let's even do this a little faster. Tired of using X, let's use the letter R. So r plus 2 is strictly greater than 1. Alright, having done this, we would have two possible solutions. R plus 2 is greater than 1, or negative of that, r plus 2 greater than 1. Simplifying each part, r is greater than negative 1, negative r minus 2, negative r is greater than 3, r is less than negative 3. I'm dividing by minus 1, which is why I reverse that inequality. We can just let's look at graph in the solution. Instead of going through the individual items, I'm going to just go ahead. Here's negative 1, negative 2, negative 3. And this time I have r is greater than negative 1, so it would be everything to the right of negative 1. Notice the open circle because of the inequality that we have. There's no equal sign, so although the boundary is negative 1, you're not including that negative 1. Okay, let's look to the next inequality. You had negative 3. R is less than negative 3. Will be less than negative 3 is everything to the left of it. So this is our final solution. Okay. And we will write our solution set in the same way as we would read off from here the set of r's, such that r is less than minus 3 or r is greater than negative 1. Okay. Alright. Somebody asked, could we do this from the graphical method? And the answer is yes. If we asked where was our house, if I looked at the absolute value, what is inside here, think about where am I putting my house. So I'm solving for r. So r would be at negative 2. So if I put in negative 2, my house is here, right? And how far am I going to, well, what's the distance? And I'm going to be moving more than one unit either side. So if I go 1 unit, let's put in some things, negative 1, negative 3, I know that looks a little bit bigger, but it's okay. Right, so if I'm supposed to go from home and move more than 1 unit, when I do that to the right, I am going above negative 1. So indeed I match up with what's there. And likewise, if I move to the left more than 1 unit, then I'm going up everything below negative 3. So there we go. We match the same thing as doing it the formal way. So yes, when they're simple enough, you can do that. Alright, let's do another. Sometimes it's not, you don't know whether it's an and or an or yet. So suppose I have this, 3 minus, what do I want? Say x minus 2 less than minus 1. Okay. Suppose I have this inequality. Do not go ahead and just start and say, oh yes, I've seen a less than sign, this must be an and. what we want to do is we want to rewrite. So if we rewrite this inequality, we would actually, let's rewrite it so we have only the absolute value on one side, everything else on the other. So in rewriting I get, let's get rid of the 3. So I get minus 3, which is minus 4. There is a negative sign here. I want to get rid of it. So let's divide throughout by -1. But if I divide through by -1, then this reverses the inequality. And so now I have the absolute value of x minus 2 is greater than +4. So when you looked at this initially, you might be tempted to say, oh, there's a less than sign. Is this an and statement? Right? But what you want to do is you want to simplify the inequality and have the absolute value on one side, get the and look at the inequality that you have, and then determine should it be an and an or, because as we see here the answer was no, it's not, right? Because from this simplified version we now see that this is a greater than, so it's really an or problem. So we can proceed either by the graphical method or by taking each individual part. It is simple enough for me to go from the graphical method. Where will I put my house? Anybody? Right. So if I look inside here, my house will be at +2. I'm going to move more than 4 units from 2. So if I move 4 units this way, I would have gotten to 6. But it's an open circle, and I'm going greater than that. So more than 4 units from my house. Next, if I look the other side and I move 4 units to the left, I would end up at -2, but I want to actually go more than 4 units, so it's an open circle. Sorry about that. Right, so if we went 4 units to the left, you'd have -2. It's an open circle because of the inequality. And now I have gone more than 4 units, but this time to the left, so I shade the appropriate region. If I look at this solution set, my solution is the set of x's such that x is less than -2 or x is greater than 6. Alright, so be careful. Okay. With that in mind, let's now move on to the and statement. Alright, so remember, if we have the less than symbol, there were 2 ways of simplifying this. Either we could sort of sandwich it between its positive or negative, or we could look at the individual parts, x is less than k and -x is less than k, simplifying as we go through. Oh, alright, so let's see what we can do. Absolute value of x plus 1 is less than or equal to 4. Well, let's look at it from the algebra point of view. What it's saying is, whatever is the expression in here, I'm going to write it back. Providing this side is a positive number, then I will be able to sort of sandwich this in between its positive and its negative. Now again, looking back at our previous lectures on inequalities or combined inequalities, how do we solve this? Well, we need to get rid of the plus 1, so to every part I will subtract 1, and I will end up with minus 5 less than or equal to x is less than or equal to 3. The graph of this will be, here's negative 5, somewhere here there's 3. I will put a closed circle at those points, and I will shade everything in between. Okay. So my solution set is exactly what we have written here. Solution is a set of x's such that x is between and inclusive of the endpoints negative 5 and 3. Let's do another one like this. 2x minus 1 is less than 3. Okay. Alright, so we could simply remove the absolute value and sandwich ourselves between positive and negative 3. Same style of inequality, the less than symbol. Again, how do we solve for x? We're going to first add 1 to all the parts, and in doing that we end up with negative 2 is less than 2x, which is less than 4. Now I need to get rid of the coefficient of x, which is 2. So if I divide throughout by 2, nothing happens to the inequality if I divide by a positive number. So this is just negative 1 is less than x, which is less than 2, or another way of saying this, x is greater than minus 1 and x is less than 2. Right. Graphing this on the number line, so here we'd say have negative 1, 0, 1, 2. Here's our x. We would have an open circle at each of these and graphing or shading in between. Okay. Don't forget to write your solution set. Solution is set of x's such that negative 1 less than x less than 2. Okay. You can always check your solution. Do you remember that we did that in the combined inequalities? So don't forget those skills that you had. There are some regions here. So if let's just put in a couple more numbers. Negative 2, here's 3. If I take a number, so if I'm doing my check and I say, let me check, does x equals 0 work? It should work. If it doesn't work, then I've done something wrong. All right. So that's in the shaded part. So it should work. Let's see what we have. 2 times 0 minus 1, the absolute value of that, is this less than 3? Absolute value of negative 1, is this less than 3? 1 is less than 3. So that's a true statement. I'll only check one other region. I'll check the positive. So if I took let x equal to 3 on this number line, which is here, it's unshaded, so it should not be unshaded, so I should end up with a false statement. Let's see if I really do get a false statement. 2 times 3 minus 1, is this less than 3? 6 minus 1 is the absolute value of 5. Is 5 less than 3? This is false, which is why it remains unshaded. You can check the other region, putting in something like x is negative 2 and you'll also see that that gives a false statement. So do remember to incorporate some of the things that you learned from previous sections here as you go through. Alright, at this stage, most of the questions that you'll be doing will be somewhat of this sort, but let me just throw in another example of when you will really need to separate things, if you wish. So that was question number 5. Let's look at number 6. Oops. So if I look at number 6, 2x minus 3. Right, so if we look at this question, 2x minus 3 is less than or equal to x. The fact that we have a variable on one side, right, instead of a number, on the right side instead of a number, it's not as easy for me to just go ahead and say, oh, this is between negative x and x, using the combined inequality, because in the process I can't really solve, or at least not easily. So in this particular case, it would be more useful for me to look at the two parts of the inequality. That is, we have to separate them and use the word and. Whether I go from here and use the word and, which is exactly what's happening, or you start at the beginning here and say 2x minus 3, that is a positive part, and you have the negative, x, sorry, putting in the wrong thing. Alright, let's solve each part. What do we get if we subtract x from both sides? We have x minus 3 less than or equal to 0. X is less than or equal to 3. Expanding, negative 2x plus 3 less than or equal to x. Negative 2x minus x. I'm rearranging. Minus 3x is less than or equal to minus 3. If I divide by a negative 1, then I also have to reverse that inequality. Oops. Sorry, I'm dividing by negative 3. And so I end up x is less than or equal to 1. I'm sorry, greater than or equal to 1. Thank you. So I have these two parts. If I look back or, combine them on a number line, I can put in, so here's 0, 1, 2, 3. It's an AND statement, so by now you can go ahead putting in your everything on one line. Whenever you don't see it all at once, then by all means use the other method of looking at the individual lines, and then since we're using an AND statement, that's really the intersection, right? It's the intersection of the two number lines if you were to do all the parts up. Alright, now for x being less than 3, you would be moving this way. X being greater than minus 1 would be everything going that way. Where do they overlap? Where do they intersect? Well, they intersect right here in the middle. So our final solution will be the solution set of x's such that x is between 1 and 3 inclusive. You can take a test value if you wish. So if you want to check, you can take a test value in here. A good test value would be x equal to 2. If I put it in the original inequality, I end up 2 times 2 minus 3. Is this less than or equal to 2? And the answer is absolute value of 1 is less than or equal to 2. So 1 is equal to 2. It works. If you tested these regions, they would not work. So if you tested, say, x equal to 4, you'd get a false statement. I leave that to you. If you test the first region out here, say using 0, which is very quick for me to do, absolute value of negative 3, is this less than or equal to 0? 3 is less than 0. This is a false statement, hence it's unshaded. So again, the only solution and our final answer is what is shown here. Okay. So bear that in mind when you are working with your absolute values. We can, if we go back, we can do things in a very simple way. That is, looking at the absolute value as, let's bring that up. We can look at it in a simple way, as shown here. Absolute value, when it's on the left hand side, is greater than some non-negative number. Then you have an OR statement, and when we have the absolute value equation and it's less than a non-negative number, then it's an AND statement. And then proceed, especially with the AND statement, you can have two individual parts and combine, or work with the combined inequality. All right. So hopefully that that explains much of your questions on absolute value, at least in one dimension. After we discuss functions, then we will work with these again, but in the 2 dimensions, so on a plane.